PE Engineer, Professional Engineer Examination, Canada, December 2019 examinations. 16 CIV A2, Elementary Structural Design, 3-hour duration. PE Professional Engineer, Canada, December 2019 examination, 16 CIV A2, Elementary Structural Design. So we will go through this examination. These are the notes, the general notes for candidates, and these are the codes: steel, concrete, and timber. The student can go through this one and understand the requirements. So you see, this is part A. Do 2 of 3 questions. Part B, do 2 of 3 questions. And part C. Okay. So we have these drawings associated with those questions. Now I'm going to solve the question in part A. Referring to figure A1, the truss shown is subjected to the service loads reported in the figure. Design the compression member FG out of back-to-back angles. Also provide the space as appropriate for the interconnection of the angle to achieve the designed forces. You may assume a 10 millimeter gap between the angles. Okay, so it is this question. Now this is a truss, and the question asks to design this one compression member. So this one compression member GF. So the first step is to analyze this truss and to find the force in this member GF. How can I solve it? Okay, now let me take a section here. Okay, for the first time, sorry, we need to compute the reactions R sub A and R sub B. Okay, R sub A, how can I find R sub A? R sub A, I can take moments around B, sorry, around D equal to 0, and any moment clockwise considered as positive. So this will give us RA multiplied by 9 meters minus P1 multiplied by 3. This one minus P1 multiplied by 3 minus this one P1 multiplied by 6 equal to 0, from which we can solve to find RA equals to 1.333 P1. Okay, now so I have just found R sub A, this reaction. Now I can take a section here. If I take a section here, then this force FGF, so FGF, it is compression as is given in the question. So if I take the left hand side portions, because if I cut here, the structure is theoretically divided into 2 parts, one to the right and one to the left. I can use either one. Now I will be using the left hand side part as it is easier. So if take moment about point B, point B, you see this one, P1 passes through B, so there will be no moment. So taking the moment about point B and everything clockwise is positive, so I have moment from RA and F sub G. Okay, that means RA multiplied by 3 minus RA multiplied by 3 minus FGF multiplied by 4 equal to 0. Okay, now, so R sub A equal to 1.333 P1 minus multiplied by 3 minus F sub GF multiplied by 4 equal to 0. From this one we can conclude FGF equals to P1. So now P1, how to calculate P1? So P1, you see P1 in the figure, it is 75 kilonewton live plus 90 kilonewton dead. So these are the working loads. They must be multiplied by load magnification factors or load factors. So load factors I can get from here. For dead load, I'll multiply dead load by 1.25 because I have only dead and live load. And live load multiplied by 1.5. So here P1 will equal to 75. It is the live 75. It will be multiplied by 1.5 plus the dead load, which is 90, it will be multiplied by 1.25. From this can be kilonewton. So FGF, because it is equal to P1, and then it will equal to 25 kilonewton compressive force. Okay, so now I have computed the compressive force. After I compute this one, I'll go design the member. Design the member as back-to-back angle. So it will be like this. Angle is something like this. So it will be angle to angle, and the gap will be 10 mm. Okay, now I am going to design this member.